This is Scott from KIG. It is April 21st, 2023, and welcome to the front portion of our shop here in Clinton, Massachusetts. Today we're going to do a runoff video or videos of this 2018 Whaley dual circuit 8-ton nominal air-cooled Glycol Chiller. And first we're going to walk around the unit and talk about a couple things. This unit is truly a dual circuit chiller. So what does that mean? It means we have the condenser compressors, two completely separate ones on top of the unit. We also have two independent evaporator braze plate heat exchangers. One of the nice things about this also is it's also a two-pump system. We have a 1/2 horsepower chiller circulation pump, which draws from the tank and then splits off and goes to both the circuit 1 and circuit 2 evaporators. Then completely separate is we have the 2 horsepower process pump here that draws from the chilled water tank and goes out to the process. Now on the back here we have 2-inch NPT connections. Because we have the 2-pump system, it solves a lot of problems as far as dialing in the chiller when it's out in the field is one thing. Also, as far as a bypass, we really don't need to worry about a spring-loaded pressure relief bypass in the glycol loop, which is important on a single pump system to satisfy the flow coming back to the evaporators. In this case here, if I was a user, I'd probably just have a small little line from your supply to return. It could be as small as a 1/2 inch with a ball valve on it. So if none of your tanks are calling for cooling, we just have a little bit of flow that that's coming back to the unit, just so the pump doesn't cavitate. You only need a tiny trickle of flow for that pump not to cavitate and burn out. Again, the 2-pump system is really an ideal scenario. While we're here on the back of the chiller, for each circuit, we have a low pressure adjustable switch, and then we also have the LAS switch for each circuit, which is low ambient or fan cycling. And really no need to touch those. A HVAC contractor may want to adjust a little bit out in the field if it's super cold. But the switching of those fans at different temperatures or pressures is one of the things that allows this thing to run outdoors in colder weather in the Northeast, as this one is. Just for our own operation and testing here, we have the covers off of each condenser up top here. That's where the compressor contactors are. We just have those off to check the condition of the contactors. And also while we were testing, we like to put an amp meter on there and see what they're drawing. And that's the hard run capacitor for each compressor and the capacitor for the fan. This is a single phase chiller. We don't have to worry about phase rotation once you guys get to starting it up. Another nice thing is each one of these circuits has for the glycol flow has a flow switch that's integrated back to the controller. Coming around to the front of the unit, there's not a fuse disconnect, but there is a disconnect that's included right here, which is kind of nice. The unit says 62 full load amps, and that's about right. I think when both, we're looking at the ratings of each compressor and both pumps and the fans. If this thing's running balls to the walls on a warm August day, it's going to be drawing pretty damn close to that. Getting back to the disconnect here, electrician, all you need to do is bring in your power here and 2 hot legs and a ground. Even though that block is rated for 3-phase, you can use it for single, which is what this is. I'll close this. And it's nice to keep the power on all the time. With a brewery or winery, it's probably going to be on all the time anyway. But as long as that power is live right now, the crankcase heaters, which are on the compressors, in the back of each compressor condenser assembly here, or the compressors are in each compressor condenser assembly here. Right now, those heater bands are on. There's actually a thermostat that controls those heater bands to be on or off. I think it's like below 70 degrees they'll be on. So it's always nice to have power live to the chiller because that keeps the refrigerant from sludging or being too cold on a cold startup if you had the system off for a while. So on our switches here, CWP is the chiller pump. They call it CWP, chilled water pump. SP is the supply pump. I like to call it the process pump, but SP is that 2 horsepower supply pump. Then chill circuit number 1, chill circuit number 2. And then we have our controller. We have the flow fault alarms. And we just have these indicator lights here also. So the first thing you do is turn your chilled water pump on. So then we have our 1/2 horsepower chiller loop pump on. And again, that's just circulating the glycol from this nice sizable insulated glycol reservoir through the 2 exchangers, evaporators, all the time. Set it and forget it. Actually, you don't really have to set anything. That valve there, that should be left open, wide open all the time, as that goes to the suction side of the pump. You never want to restrict the flow to the suction side of the pump unless it's a service issue. Then we can turn on, you don't have to cool it, but then you turn on the supply pump for the process supply, so now we got both pumps running. For our test in our shop, obviously we don't have tanks or load. We actually do have tanks, but they're for sale. We do stock a fair amount of 3, 5, and 7.5 barrel tanks here. But anyway, for our test, so the pump doesn't over amp, we have to throttle down the flow a little bit. That's our own valve we put on for the loop. A pump does like to have some back pressure. If I open that up full open, the pump would probably over amp, because that means the pump is spinning too fast. Related to that, inside the cabinet here, sorry about that. That's your contactors and overloads. Actually, it's kind of nice because we have overloads for each pump. Some chillers just rely on the thermal overload of the pump itself. So these are pre-adjusted. That's your contactor and an adjustable resettable overload for the chilled water pump and the supply pump. And then these are our breakers for the compressor and the fans, controller transformers there. I really don't have to touch anything in here upon initial startup. So we're going to, let me block this. Sorry about that. So when you have to turn at least the chilled water pump on for the controller to power up here. And it's just going to show you the what the glycol temperature is right now. Controller is very simple, and the manual is actually very, very good. We sent a link on it. For your set point temperature, you just press P once. And that gives us set point 1. It goes back and forth. I have it set at 28. To adjust it, you just go up and down. Press set point 2, or the other circuit. I just happen to have that at 29, so you can see the difference. And then if you hold, per the manual, if you hold and press in P for 5 seconds, you go into other parameters. The only other parameter you may want to change is the hysteresis, or the differential. They're both set at 5 degrees right now. That means when circuit 1 reaches its set point, the compressor stops off, the compressor shuts off, and it's going to wait till it goes 5 degrees above set point before it comes back on again. You want to run with the biggest differential possible that you can get away with, because that is what minimizes the starts and stops of a compressor. You know, if you set that differential to 1, that thing's going to be going on and off all day long, and that's what beats the hell out of a compressor. Don't have it at differential 1. Try to get away with differential 5 if you can. This system, the manual implies otherwise, but we really don't want you to see you running a R410A refrigerant system like this much below 25 Fahrenheit. On that issue, run it at the warmest you can get away with without sacrificing or hurting your process. The colder the set point, the harder the compressors have to work, as with any chiller. So we're going to run circuit 1 for a while, and then we'll run circuit 2 later on. We might have a limit. I don't know if we got 60 amps on our box here, but I'm going to turn on circuit 1. Pretty damn quiet, by the way. So this compressor is already running. Then as the refrigerant pressures build up, that's when the condenser fan's going to kick on. It's not on right now, but it'll probably be in 5 seconds or so. Yep. And so right now that's blowing hot air. So right now we're chilling. We'll bring it back to video number 2. And you can see the indicator light here, chill zone 1. We'll bring it back to video number 2 as we get down to 28 Fahrenheit. And just one side note, that's your fill port there for the glycol. The glycol sight glass. Run about 45% glycol concentration. And then the process pump. This is your supply, that's what's going out. This is your return.